This is Unit 10, Organic Chemistry. Lesson 1, Introduction to Organic Chemistry. How are organic compounds classified and identified? The objectives of this lesson: I can identify the properties of organic compounds. I can identify hydrocarbons based upon their formulas. I can name hydrocarbons using table P and Q. And I can determine if a compound is saturated or unsaturated. Do now. So the IUPAC, as a quick reminder, this organization essentially makes the rules for naming chemical compounds. In chemical nomenclature, the IUPAC nomenclature of organic chemistry is a systematic method of naming organic chemical compounds as recommended by the International Union of Pure and Applied Chemistry. It is published in the Nomenclature of Organic Chemistry, informally called the Blue Book. Organic chemistry is the study of organic compounds, which contains carbon and hydrogen. In terms of chemistry, in order for it to be an organic compound, it must have carbon. But in reality, essentially all organic compounds have carbon and hydrogen. The major sources of organic compounds include petroleum, coal, wood, plants, and animals. So why is carbon so special, and why we always have to have that in mind? The properties of carbon: because carbon has 4 valence electrons, it will bond 4 times to achieve that stable octet. So recall when we were doing our Lewis dot diagrams back in our unit of bonding, chemical bonding, each carbon has to have 8 electrons around it, and because it has 4 valence electrons, it needs to share 4 more with 4 other elements. Organic molecules also have the unique properties of sometimes forming double and triple bonds in order to fulfill all octets. So for example, these carbons are each sharing 4 electrons and 2 with each hydrogen, therefore they have 8. And these carbons, each carbon is sharing 6 electrons and then 2 with the hydrogen. So it's very unique that it can do this, and so that's how we get so many different organic compounds. Properties of organic compounds include: 1, they are generally nonpolar. That means they're insoluble in water because water is polar, but they will be soluble in other nonpolar substances. Water is polar, so they are not alike. 2, they are poor conductors of electricity, so we call them non-electrolytes because they do not form ions. So keep that in mind. That is the reason why they do not conduct electricity. 3, they have low melting points due to weak intermolecular forces. Recall the intermolecular forces, or the IMFs, are those forces in between different molecules. So this is between our 2 molecules. Within our molecule, we have those strong covalent bonds. And the final reason for is they are very combustible or flammable. That's why we use many hydrocarbons in our cars to help us power them. Organic compounds that contain only carbon and hydrogen are called hydrocarbons. So that is a definition you must remember. Table Q tells us the homologous series of hydrocarbons. So these are our 3 main classes of hydrocarbons. Alkanes have only single bonds, and we will follow this general formula where N is the number of carbon atoms. So for example, in this compound called ethane, there are 2 carbon atoms. So Cn would make this C2. If I plug in the N here for 2, so 2 times 2 is 4, plus 2 is 6, H6. So we can see that the alkanes follow this general formula, and if we count up our structural formula here, 2 carbons and 1, 2, 3, 4, 5, 6 hydrogens. The alkenes are different in that they always contain at least 1 double bond. As a result, they have a different chemical general formula, where C would be 2 here, so this is C2. H would be 2 times 2, which is 4. So if we look at this formula, 1, 2, 3, 4 hydrogens and 2 carbons. Alkynes are next unique because they have a triple bond. They have 3 bonds, and they follow this general formula. So this would be C2, and then where 2 times 2 is 4 minus 2, H2. Using table P in combination with table Q, the table P shows us the prefixes of all of the carbon atoms. So if we have 1 carbon atom, in our compound, we'll call it a meth. If it is an ane, if it only has single bonds, it would be a methane. In this case, we have 2 carbon atoms, 1, 2. So that's the eth, and because there are no double or triple bonds, it's an ane. So we would call that ethane. So some more examples here. Give the prefixes for these. So if we just look at our table P here, we should be easily see the number of carbon atoms would get us those respective prefixes. And then to check your work, now naming hydrocarbons, I did a brief summary, but to put the P and the Q together, we can simply name hydrocarbons this way. We first look to see if there are any double or triple bonds. In this, they're all single bonds, so therefore it's going to be an alkane. Alkanes have only single bonds. Any alkanes will end with A and E. Then we'll see how many carbon atoms. 1 carbon atom. If we look back on table P, we'll see 1 carbon atom as the prefix meth, so then this is methane. In contrast, we're going to look on this one. There's a double bond, therefore it's an ene, an alkene. We're going to end it with ene, just like the name alkene ends. And because there are 2 carbon atoms, when we look up in our chart, eth has 2 carbon atoms. Therefore, this compound is called ethene. And in organic chemistry, the spelling is important. It must be perfect. Naming hydrocarbons with a triple bond, we'll do the same thing. If it has a triple bond, it's an alkyne. Therefore, we will count up the carbons. 2 carbons is eth, and if it has a triple bond, it's an ine, so it's an ethyne. Here we count up, there are no double or triple bonds, therefore it's an alkane, so we'll end with ane. 1, 2, 3, 4 carbon atoms gets us the prefix bute, so this is a butane. So the steps you will follow to do that, so I walked you through it and I'll give you time to practice. 1, count up the number of carbon atoms. So how to determine the type of hydrocarbon from a formula using table Q. So if I only have a formula, such as this formula on here, these are the steps you'll follow. First, you have the carbon atom. Count the number of carbon atoms. So in this case, I have 5. If the number of hydrogens are double the number of carbons, it is an alkene. If more than double, it's an alkane. If it's less than double, it's an alkyne. So in this case, 12 is more than double 5, so it's an alkane. So we'll follow this rule here. Saturation is defined as compounds that have only single bonds. So compounds like fats that are saturated have many hydrogen atoms, and this requires only single bonds. So alkanes are saturated with single bonds, and that's how you'll remember. Alkanes are always saturated, and compounds that are unsaturated have double and triple bonds. Therefore, they have less hydrogen atoms, and they are unsaturated. Alkenes and alkynes are always unsaturated. So some quick examples I'll do with you. Step 1, to determine the name, count the number of carbons. So there are 2, so we'll use the prefix eth. Then I'm going to count the hydrogens. If they are double the carbons, it's an alkene. So 6 is not double 2. If it's more than double, it's an alkane. 6 is more than double, so it's an alkane. So this would end in ane. So same rule steps. 5 carbons makes it a pent. So this is a pent. Is 12 double 5? No. Is it more than double? Yes. Therefore, it's an alkane. So this is pentane. Carbon 3, that's a prop. Is 6 double 3? Yes, 6 is double 3. So this is a propene. 4, that means it has a prefix bute. So this is bute. Is 6 double 4? No. Is 6 more than double? No. Is 6 less than double? Yes. This is a butane. So here's those spelled out if you can't read my handwriting. Now quickly, which ones are saturated? Okay, check your understanding. And 3 and 4. And now you can identify the properties of organic compounds. You can identify hydrocarbons based upon their formulas. You can name hydrocarbons using table P and Q. And you can determine if a compound is saturated or unsaturated.